Okay, guys. My brother just had welcome or well, it was like uh back to the school year test kind of for his first grade, and there was this problem on page 3 that was particularly difficult. Um, yeah. Uh, no one else in his class was able to solve it. Except this kid named Maximilian. But um, yeah. But other than that, he seemed to not be able to figure out the way to solve it, and his friends couldn't either. So I thought I would kind of showcase how to solve this, and so um, if you are in first grade and you can't solve this problem, uh, you know, it's okay. Like a lot of other people can't solve it either, and um, yeah, it's something that you'll just have to practice and learn, I guess. So, Alex has 32 apples. Jonah has 9 apples. Alex has a magic box that makes the number of apples he has increase as described by the function a equals t to the fifth, where a is the number of apples and t is the time in seconds, while Jonah's magic box makes it increase as described by the function a equals 3 to the tth power. Assuming fractional apples are allowed, find the exact amount of time in seconds it would take for Jonah to catch up. And he wrote, I don't know. He spelled it wrong, but he's in first grade, so I guess it makes sense. So at first it seems almost impossible because you're starting out with like some set amount of apples. Um, but this is kind of part of the trick question. So the main thing to notice here is that 32 as described by Alex function, is equal when a equals 32, t must be 2 because 2 to the fifth power is 32. And then if you take a look at this, 3 to the second power would equal 9, and that's 9. So then actually what you see here is that it's just the exact same as the parent function, but all you have to do is realize that, oh, it's just a number if after 2 seconds from the parent function. So you don't have to calculate it with each of the functions translated somehow, right? So then suddenly the question seems possible. We're basically halfway through it now. So, okay, you're solving for the time when the Jonah catches up to Alex, so that's when the apples would be the same. So then you would just write, t to the fifth power equals 3 to the power of t. Okay, great. And then now we just kind of go through the classic way to solve it, I guess. So you want to get rid of the, or you want to bring the power down here. So then you would just take log base 3 of each side, and then this 5 would come out. So then you would do 5 times log base 3 of t equals just t. Okay, and then here, right? And then it's basically just applying the concept of the Lambert W function. I'm pretty sure that was taught after first grade when I was still in elementary school, but things change, I guess. I don't know. So then in that case, it would just look like 5 times log base 3 of, and then we'll just use a as a some substitute variable here, so then it just becomes e to the a equals e to the a. You see that? So then basically a just comes out. 5a times log base 3 of e equals e to the a, and then suddenly we can move the a to the other side. So then this, I'll just write it over here. 5 times log base 3 of e equals a to the negative first times e to the a. And that's so close to the format it's supposed to be, but a is raised to the negative first power. So what we can do is raise everything to the negative first power, but then, which would cancel this negative out, but because the negative 1 gets multiplied to this a here, we'd have to make both of them negative, right? So basically, it would just become negative 5 times log base 3 of e to the negative first power, which equals negative a times e to the negative a. And suddenly, we can apply the W Lambert or Lambert W function. So, what would it be? So in this case, a would be, okay, so a would be, normally would just be that, but then because this is in the case of negative a, so then you would just do a equals negative w, negative, negative 5, okay, let's bracket times the log base 3 of e to the negative first power, right? But then this isn't quite the answer yet, because remember we substituted e to the a for t. So then time would actually equal e to the power of negative w negative 5 times log base 3 of e to the negative first. Okay, it's kind of hard to see, but basically here, oh wait, no, actually that's okay, but then we have to remember what we did at the beginning. So basically, the real answer here would be, I'll just draw an arrow over here. The real answer here would actually just be e to the negative w of negative and then 5 times log base 3 of e to the negative first power, but then we have to remember to subtract the 2, because remember it started out with 32 and 9, which means t starts out at 2, and that equals t. Yeah. And also, yeah, you can, this isn't the only format to do it, but it requires like log rules, and I'm pretty sure that comes, you're taught that like after first grade, so I don't think you have to worry too much about that. Okay, so yeah, and yeah, if you have any questions, I guess you can ask them, or if I don't think I made a mistake, I might have. If I did, then you can just tell me. And if you have any more specific questions, you can either ask your teacher, or if that's too scary or something, you can just ask your mom and dad or whoever your guardian is. I'm sure they can help you out. Okay. Bye bye.